Hello guys, today we'll be seeing about introduction to Arduino and working of a servo motor. First of all, Arduino. Arduino is a development company that produces development boards from Italy. These development boards are used in numerous ways to make our life easier in automation, in robotics, in sensing techniques, etc. So, introduction to Arduino. Basically, there are lots of Arduino boards like Arduino Uno, Mega, Nano. The most commonly used board is Arduino Uno. In Arduino Uno there are lots of features. The main thing control is because of this IC, that is 8ML80 Mega 328. This IC controls all the inputs and outputs and all the transmission that occurs here, all in digital logic. So first, the USB jack. This USB jack is used to power as well as to provide serial communication, that we'll be discussing further. And this is the RxTX pin for communication using serial communication, we'll see it further. And the LED, this is the main LED. This LED is linked to pin 13 of digital. So whenever this pin is triggered, this LED will glow. And the power LED. This power LED indicates whether the board is powered on or off. This is a DC power jack with an adapter that you can power this board externally when you are not uploading the code. Once you are done uploading, if you want to use it somewhere else, you can use this jack, power it and run it. Now coming to the pins. These are the digital input and output pins with a ground here. In some of the pins marked in number 1 here with a dash. Those pins are used for pulse width modulations that we'll be seeing further. And here this is for digital, and this is for analog input output pins, like for analog devices like potentiometer that give a varying output signal. And here you see there are two grounds, V input, 5 volts out, a power supply, 3.3 volts power supply, reset pin. And this button is a reset button to reset the Arduino board. And these are voltage regulators, 7 voltage regulators, all other features. Now, getting started with the interface. Arduino is an open source environment, IDE. It can be downloaded from arduino.org based on your necessity of your computer, whether it's a Mac or Ubuntu or Windows. Preferably go for Windows, in which you can easily initialize the COM ports. Now, I'll show you how you launch it. Once you launch the Arduino IDE, this screen pops up. Maximize it or minimize it. Maximize it or adjust the size for your requirements. Now, we'll explore the tabs. File. In this, you can open new project, open recent project, sketch, examples, close, save as, print a project, etc. Here you can edit it as a forum, HTML, page, indentation, that things. Sketch will upload the sketch, you can verify it, export as a binary, verify that things. In tools you will find a serial monitor, the board, the port and all. Help is for help that will get directed to your Arduino IDEs.org. We'll have inbuilt documentation. So here, this is the thing. Now here, you'll type the code here and then execute it. So once you're done it, basically first plug in the board. Once you plug in the board, there are two main things to be done. First, go to tools and set the board. The board you're using is Arduino Uno. So set this board correctly, and then the port in which the serial communication is going to take place from the system to the board. Correct that port corresponding to the board and name COM3. So press COM3. So with this, you're done now set up the board with your laptop. So now, how to upload a code and how to run it. So basically, there's a if you define examples, so I'm going to file, examples, basics, blank. This is the most basic program. This is the blink program. So now, see here the void setup, the code is written over here, the looping iterations are written over here. Now, how to upload it and run the code. So you see a tick mark over here. This tick mark is for compiling, and this is uploading. When you always remember, when you upload the code, it compiles by default. So when I click upload, it's compiling sketch here, and you can see the status over here. They were running that circulating blue one. Now it's uploading. Yeah, now it's uploaded, and you can see the data bits it's used, maximum of 2048 bits, available bits in the storage space. It has used only 2% of the program space. So with this, you have uploaded a code to your board, and the board performs the corresponding action. As per here, the LED is blinking for every interval of 1 second. So now we are done with the getting started part and uploaded our program successfully to our board. So now moving on. Libraries. As a basic programmer, you will know libraries in C, C++. All these things have some inbuilt libraries where you use inbuilt functions, inbuilt sketches, inbuilt the example code that you use. Like in C++, you use apps to find the modulus. So in case even Arduino has lots of inbuilt libraries. For example, when you use Servo, you need to include a library called servo.h that takes all the things from the servo.h, and we can access any of the function that we need to use in it. So you can make your own library, download libraries from the net. If you want to import library, go to Sketch. There will be an option called import library as a zip file. Now this is the Arduino IDE. As I told you, there are button bars over here, the input edit area where you write the code, and the status bar done compiling. These things are shown in this. Now moving on. Yeah, select the CL port and board as I told you. It's an important step to be noted. Then using Arduino, coming back. First write your sketch, then press compile button to check for errors. Or you can straight away upload, but it's always recommended to compile and then upload. Then try the blink sketch. That's the most basic thing. So first the code, it compiles, then compiling, applied it, RxTX flashes. This indicates serial communication that we'll be discussing later. Then blink, blink, blink. The LED starts blinking interval of 1 second. Now, serial communication, the most important part. How does your programmable board communicate with your computer? It basically works on digital logic. So information passes as high and low variable outputs. So as bits of zeros and ones. So waveform, 1 is high, 0 is low. So if a character is to be transmitted, say character B, the corresponding capital B's ASCII value will be 96. So that will be decoded as a binary digit. That's 0, 1, 0, 0, 0, 0, 1, 0. Each one 0 corresponds to low, 1 corresponds to high. So the resulting waveform will be low, high, low, 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 high and low. So imagine for one alphabet, it's this much wave needs to pass. Then for imagine complex programs, how fast the serial communication takes place between the board and your programming system. So this can be done with the use of digital write and delay commands that will be really studying further. Yeah, compiling turns your program into binary digits, ones and zeros. Okay, so compiling turns your word to ones and zeros, and uploading sends these bits to a USB cable to the Arduino. This is the serial communication starting part. There are two LEDs like RX and TX. RX blinks when Arduino receives data, TX blinks when it transfers data. So with this we can satisfy ourselves that communication is taking place. So basically input output. For what things you can use Arduino to program. Suppose there's actuator that takes the output and that gives us input to Arduino. And Arduino is programmed with a laptop or system. So this Arduino has some commands. So input transducer. So from here the control flows into here, there's something happens and there's output transducer. Like a LED blinking or something happening. Then digital input output. Digital input is binary value. It's either 0 on or off as discussed before. Now coming to Arduino's digital input output interfacing. There's some inbuilt set of commands that we need to know before going into programming to Arduino. The best things are pin mode, where the parameters pass the pin and mode. Pin is the pin number that you're going to use, and mode is input or output. The pin is going to give some data or take some data. Now digital read. This is to power up the pin and read the pin's form. Pin's status. You give it as pin number. This reads high or low input from the pin. So basically digital pin 3 will read whether it's high or low and it will return as a string. Like digital write. This is to write the data to the particular pin. So digital write pin comma value, this to our parameters. So digital write pin of 5 comma high will give 5, it will trigger off. So electronic stuff into this. Output pins can provide always 40 milliamperes of current. It's the main thing to be noted, but this case can be modified using pulse width modulation that we'll be seeing shortly. Yeah, the basic blink program. Now explaining it line by line. Void setup. This is the part where you initialize the pins as input or outputs. So here you're going to use the inbuilt LED as I mentioned before, that's connected to digital pin number 13. So pin mode is 13 comma output. This is going to be an output pin. Okay, so what setup you initialize this? Now coming into looping part. In the looping part, you initialize first digital write 13, high. This means I'm powering up pin number 13. Then delay of 1000. This is to be given always in this is like 10,000, say 1000. That means as 1 millisecond. It's like 1000 milliseconds is the unit for this. So basically, it will be delay of 1 second. Then delta write 13 low. It will be low for again 1 second. So it will be blinking in intervals of 1 second. Input output pins discussed before. So input and output pins of digital and analog is only input. You can only give input of signal as analog can only accept as input, but digital pins can give us both input and output pins. Pulse width modulation. As you see in the board, there will be 2 ports for 5 volts and 3.3 volts. But some of the sensors need to take volts, like 2.5 volts maybe the voltage. What can you do this to happen? So you can't directly supply 2.5 volts, but you can use the pulse width pin. You can really produce fast the signal. So 70% of it is taken into consideration and 20% is neglected. So this thing can be done using pulse width modulation. Pulse width modulation duty cycle. This is one of the important things that determines the output voltage. So output voltage will be on time by cycle time into 5 volts if you connect a 5 volt pin. The on time will be 0.75 seconds, cycle time will be 1 second. So if you do it, it will be 1 by 4 into 5, 3.75 volts. By 2 will get 2 volts. So cycle length is always fixed, a number of cycles per second. Keep it into mind. The pulse width modulation pin. As I mentioned before, like remember I told you there will be some lines near some pin numbers 3, 5, 6, 9, 10, 11. Those pins are pulse width modulation pins. Only these pins can be able to produce pulse width modulated outputs. So these are the pins here, and the command to use this analog write pin comma value. Pin is the pin number, and duty is always taken from 0 to 255. That is 256 bits. We take 0 to 255, so we totally get 256 bits. So if you want a 50% duty cycle, we only want half of the bits to be transmitted. So take from 0 to 128. 0 lower limit is automatically assigned. You only assign the upper value in this command. So 50% duty cycle. Analog write 11,64. So this gives 20% duty cycle. Yeah. Now moving on to servo motor. Servo motor is a special type of motor used for special electrical purposes. A servo motor comes in different variations for 9 volt voltage load, 12 volts power load. A servo motor can rotate to 0 to 180. It has only 180 degree offset. You can't be able to rotate it for total 360 degrees. So now there are 3 pins of servo motor. One is the ground pin, one is the power pin, other is the control pulse width modulated pin. These pins are the main important pins. Yeah, there are some special purpose applications. Suppose you want to monitor, use a sensor to monitor certain angle continuously for a long period of time. For this application, you can use a normal DC coil motor. So for this thing, you can use the basic servo motor, which works on servo mechanism. So servo motor can use for special purposes, a special kind of DC motor, but it uses shafts inside. So servo mechanism is an automatic device used to correct the performance of a mechanism by means of error sensing feedback. Servo mechanism has it's a closed loop system in which you have a feedback. So there is a motor here in the gearbox, and the output is given to the shaft, to the outer kind of plastic thing. In there, to the shaft will position sensor, which positions it and gives a negative error feedback. Based on this, the error amplifier determines the servo mechanism, and this is called the reverse servo mechanism. The third pin accepts the control signal. It's a pulse width modulated signal. It can be easily produced by all microcontrollers and Arduino board. This accepts the signal from your controller that tells it what angle to turn to. So based on that, the angle that turns is determined. The control signal is fairly simple compared to that of a stepper motor. It generates a pulse of varying length that gives, and corresponding to that angle, the angle of the motor changes. Yeah. Now let's see how we correct a servo motor. First, there are 3 pins of servo motor. One is the ground, the power, and another is the pulse width modulation. Now connect the black wire from the servo to the ground pin of the Arduino. Black always goes to the ground. The red wire to the plus 5 volt supply in the Arduino, and the third wire, which is usually in orange or yellow color, to the digital pin of the Arduino, by which the pulse width modulated output is going to be given from the Arduino to your servo motor. Yeah, this is basically how your setup should look like. this is your servo motor. The servo characters for jumper, male to female, not an issue. Straight away character red to the +5 volt, and one of the ground to this black wire to the black wire to the ground, and the other third wire to pin number 9, white or orange to pin number 9. It's a pulse modulated pin. So we are going to use pin number 9 to program our servo. Yeah, the basic servo code. As I told you about libraries, servo.h is an inbuilt library which is used to use all the servo related functions. So now coming to servo, my servo. My servo is like, its servo is like old class, which my servo is the object that's created by you to control your servo motor that is attached to the Arduino board from your computer to your device. Now end position is 0. It's like a very position to store a position from 0 to 180. You're storing it as an integer 0. Now void setup. In this you initialize the things that needed to your program. So here my servo is the object, and attach is like similar to the pin initialization over the normal blink thing. So use your object dot attach dot 9. Pin number 9 is pinned to the servo object, and this pin number 9 is going to be connected to the pulse modulated pin of your servo motor. Now coming to the looping part. Here always make sure you always make the servo to rotate from 0 to 180 degrees, because apart from 180 degrees it doesn't go, servo will get damaged. So basic for iteration, like your C++ program, initializing a variable position from 0, and this will run till position reaches 180, less than 180 in steps of 1 degrees, in step of 1 degrees, as you see. Now my servo is object dot right of position. So this will keep on at the position for each and every state and delay 15. So it will get 15 milliseconds. So first, when position is 0, the position will be 1, and after 15 milliseconds position will become 2. So it will change from 1 to 2. And now after this group gets over, the position will be 180. Now from again 180, I'm going to decrease it in steps of 1 till it reaches 0. So same thing. So the reverse thing happen. If you want to visualize it going very fast, so give plus or equal to 25 or 35 and delay that time second. So at every turn there will be a bit time interval, after which it again turns back. Now you can even use a servo with some other component. You can map a servo with some other sensor. So let us see servo controlling using a potentiometer. The same thing when you want it to like tilt a camera or sensor connect to any servo. Like if you want to map the based on the current going, you can connect any type of sensor you want. Here I'm going to show using a potentiometer. So potentiometer, whereas the potentiometer is for it's 2 per 10 bits, I guess, from 0 to 1024. So 0 to 1023. So each of this values should be mapped to the degrees of rotation of servo, that is from 0 to 180 degrees. So only thing is we'll add extra potentiometer in the between when you connect to the ground and to the +5 volts, and this thing to be one pin of potentiometer will go to the analog pin. So basically this is your circuit diagram. So controller, the ground goes to the ground, and the potentiometer is added to the ground, common ground, with the pulse modulated +5 pin and to the pin 0 of analog. So the code, same thing as if you see include servo.h, the servo library is taken out, then servo, my servo is the servo object that's going to be used, and in port pin equals 0, the analog pin that you're going to use in potentiometer and the previous circuit is pin number 0 here. So we initialize int port pin equals 0 and int value, the value of the potentiometer will come from 0 to 1023. So I'm initializing as int value can store till 2 bits, so that range will come in int range in the memory bits. Now setup, in which like before code, same like here my servo attach.9, we again attach the pin number 9 to servo, the pin number 9 is attached here to the pulse modulated pin, and looping statement. Here's the main part. Value is equal to analog read of port pin. The port pin is 0, analog read is used to read the analog value from the potentiometer, and that is stored in value. Now again I'm going to map value with something else. I'm going to replace the value of value that's got from here VAL with map of VAL from 0 to 123 to 0 to 179. So value that's got from 0 to 123 of the value from the potentiometer, this val number that's stored in this memory will map to the degrees of rotation of the servo motor from 0 to 180 degrees. So like this is 1 degree, like 0 to 179 degrees, because 180 is the maximum bit. So with this values, assign a value for the servo to rotate from 0 to 179. Now, like before, my servo dot write of value. So your servo motor will align itself to the value that's got here, that degree that's got here, from 0 to 180 degrees, and delay of 50. This is used to delay the servo for the next iteration.